Hi, we have a problem on 3.1 functions, and this one is applications. And problem is very similar to 88 and 89, although 88 and 89 deals with triangles. I decided not to do one exactly like that one because it would be kind of dead giveaway of how to do those two problems. But what I want to do is find the area of a geometric shape and write the in functional notation. I think 88 and 89 deals with isosceles triangles. So if you don't know what the formula to find the area of an isosceles triangle, then that means you're going to have to go look it up. I'm going to actually do a problem that's more difficult than what you're doing. And so what I'm going to do is find the area of a trapezoid. Now, finding the area of an isosceles trapezoid is isosceles triangle is fairly easy compared to finding the area of a trapezoid, because the formula for finding the area of a trapezoid is much, much more difficult. But what I'll do is I want to find the area of a trapezoid where one base is twice the other, and the height is 2 units more than the smallest base. So a trapezoid kind of looks like this. That's kind of what a trapezoid looks like. And what a trapezoid is, it's basically a quadrilateral that has two sides that are parallel to each other, and the other two sides that are not parallel to each other. Now, the thing about how to find the area of a trapezoid, now this is something you probably would have to look up. Hopefully on the 88 and 89, you should know what the area of a triangle is, whether it's isosceles or not. But on a trapezoid, it's this. Its area is equal to the sum of the bases. So we got two bases. And so you add those up. You multiply that by the height, let h, and then divide it by 2. So that's how you find the area of a trapezoid. It's the sum of the bases times the height divided by 2. And how was I supposed to know that? Well, you wasn't assigned this problem anyway. So, but that is the formula. So, and that's what I'm saying on some of these word problems. If you don't know the formulas, you're going to have to go look them up. And it's not that hard to find these things in the book and stuff, other places. But anyway, this is a quite difficult one here. Now one base is twice the other, which basically means if this one was 5 inches, this one would be 10 inches. If this one was 12, this one would be 24. So one's twice the other. Now the thing is, I don't know what either one of them are. I don't know what the h is, so I need to get everything in terms of the same variable. And then I can create a formula based on that variable. That's what all functions are. It's based on a function. It's what alpha of x means. It's a formula based on a certain variable. F of x, for example. It's a formula, f, and it's based on what x is. So here, this is a formula based on something on this triangle, this trapezoid. So what I'm going to do is I'm going to let the smaller base be x. Okay, so that's b1. Now, based on that, I can tell you everything else now, based on x. So the other one is twice that one. So the other base would be 2x. Now, which is larger, x or 2x? Well, the smaller one obviously is x. Now it says, and the height is 2 units more than the smallest base. Well, if this is the smallest base, which is x, and the height is 2 more than that, so what do you think that is? If it's just 2 more. So if this one was 5, this one would be 7. If this one was 12, this one would be 14, because it's 2 more. So whatever this is, the height is, yes, x plus 2. So based on that, I can just plug those into the formula, and they're just x's. And now I have a function based on what x is. So the sum of the bases would be x plus 2x times the height, which is x plus 2, divided by 2. Now, of course, x plus 2x obviously is 3x, and it's times x plus 2 over 2. So if you multiply the top, you get 3x squared, and then 3x times 2 is 6x over 2. Now you can break this up in 2 pieces if you want. Don't really need to do that, but it's an area formula or area function in terms of x. So we just won't call this a anymore. We're going to call it a of x because the area is based on the x being the smallest base. So if I knew what the smallest base was, if these other 3 things are true, if all this is true, if I knew what this term is, I could tell you what the whole area is. So if you tell me this was 10, then I'd plug 10 into the x, and then do the math here, and it'll tell me the area of this whole trapezoid. So you wouldn't have to plug a number into a formula every time. You would just plug one number in, and instead of plugging a number in here, here, and here, and then pop it into this space here, and this formula here, because if I told you this was 5, and this one was 10, and this one's 7, you'd pop these numbers into the formula, and you'd get the answer. But you get the same answer if you just plug 5 into this one. So you have one formula to work every time. So that's the kind of the beauty of functions, is because instead of having 3 unknowns, there's a relationship between those 3 things. And based on that 3 relationship, I create a formula or a function, put one number in, and it gives me the whole thing without even bothering with the other 2. So that's why it's kind of nice. So, but anyway, that's a problem like 88 and 89. So, and that's it.